Good morning, my dear students. Myself, Dr. T.N. Shridhar, Professor from the Department of Mechanical Engineering. All of you were at home from past 1.5 months because of this COVID-19, and most of the faculty members, they have started taking online classes, and I hope all of you are attending those classes. And as far as this particular subject is concerned, that is computer aided engineering drawing, so what we thought was, it is very difficult for the students to comprehend the online teaching, and also this particular course required to give instructions to students so that they can comfortably do problems using the software. That is the reason the Department of Mechanical Engineering wanted to start these presentations, so that we are going to send these presentations to you, so you can go through this once or twice or thrice, unless you follow the concepts properly, so that it will be easy for you to understand. And also you know that even though this particular course has been taught by different sections, I hope most of the faculty members, or in most of the sections, they would have covered up to projections of solids. I hope in some of the sections they would have started this projection of solids. So for clarity, so what I do in these presentations is, we are going to cover the projections of solids, then developments of surfaces, as well as isometric projections. And you know that already in the previous classes, we would have covered projections of points, lines, as well as planes. And today, I will be starting with projections of solids. So as you know, if I say a solid is having 3 dimensions. That is, it has got length, breadth, as well as thickness. Now since it has got 3 dimensions, and we need to present this, or we need to project this in orthographic projections, which is, we are going to do it on a plane surface having only 2 dimensions. We cannot completely describe a particular solid in one view itself. That's the reason, if I want to represent a solid, we need to draw minimum 2 orthographic views. And let us come to solids, then different types of solids generally we have. Generally, the solids can be grouped into polyhedra on solids of revolution. Polyhedra. So what is a polyhedra? A polyhedra is a solid which is bounded by planes or plane figures, and those plane faces, those plane figures can be considered as faces. They are all bounded by one another. Then we consider them as polyhedron. Then we have different types of polyhedron. So first one is, we consider that as a tetrahedron. So as the name indicates, a tetrahedron has got 4 equilateral triangular faces. They are bounded by one another. Then we have what is known as hexahedron. Hexahedron, as the name indicates, it has got 6 square faces which are bounded by one another. Hexahedron can also be considered as a cube. Then we have what is known as dodecahedron. A dodecahedron has got 12 equilateral triangular faces. They are all bounded by one another. Then we have what is known as octahedron. A octahedron is a polyhedra bounded by pentagonal faces. They are all bounded by one another. Then the resulting solid can be considered as a octahedron. Finally, we have what is known as icosahedron. A icosahedron is a polyhedra bounded by 20 equilateral triangular faces. So as far as this particular course is concerned, we will be considering only tetrahedron as well as cubes or hexahedron. But apart from this polyhedra, the most popular polyhedron which we are going to consider in this particular course can be classified as prisms and pyramids. So if I say prism, a prism is also polyhedron, which I have just drawn a prism on the board. You can just see a prism is a polyhedra. It has got two bases, or I can say two ends. So these two ends or bases, they are parallel to one another, and these two bases or ends bounded by faces, and those, then we consider this particular solid or a polyhedra as a prism. So if you just consider this particular prism has got two bases, but you can just see the shape here. I have just considered this shape to be a square face. So since this particular polyhedron or prism is having square bases, we consider this type of prism as a square prism. Accordingly, we can have, depending upon the shape of the base, as we can have a triangular prism, we can have a square prism, then we can have a pentagonal prism, then we can have an hexagonal prism. Then we need to consider this prism as right and regular prism. So when do you say this to be right and regular prism? For that I need to define one more term known as an axis. An axis can be considered as an imaginary line which will be represented something like this, that is a longer line, a dash, a longer line and a dash. So this representation can be usually used for axis. So an axis in this particular case can be defined as a line joining the center of one of the bases to the center of the other base. So I can just say that the center of top base to the center of the bottom base. Then that particular imaginary line can be considered as an axis, and in this particular case this axis is perpendicular to the base. Since the axis is perpendicular to the base, we consider this particular prism as a right prism. Not only it is a right prism, it is also a regular prism. Why it is a regular prism? Because all the sides of this particular bases are having equal dimensions. Okay. Then we have the other type of polyhedra which are more popular, can be considered as a pyramid. So what is a pyramid then? As you can see here, a pyramid has got only one base. Then from this particular base we have these isosceles triangles which originates, and they are all going to converge, and they are going to converge at a particular point, and this point can be considered as an apex, or I can also say a vertex. Apex or vertex. So I can say a pyramid is got only one base, and we have these isosceles triangles originate from this. They are all going to converge at a point, and that point can be considered as the apex. Now again in this particular, if I define the axis in this particular case of pyramid is nothing but the line joining the apex to the center of the base. We again in this particular case it is perpendicular to the base. That is the reason we consider even these pyramids also right and regular pyramids. And as you can see in this particular figure, I have considered this base to be a square. Since I consider this base to be a square, we consider this type of pyramid as a square pyramid. So then I can say, depending upon the shape of the base, we can have a square pyramid, a triangular pyramid, a pentagonal pyramid, as well as a hexagonal pyramid. Now come to this solids of revolutions. So as the name indicates, we need to rotate something. So in this particular case of solids of revolution, if I consider let us say a rectangle, and if I rotate that rectangle with one of the sides, and if I rotate by one revolution, then the resulting solid can be considered as a cylinder. So as you can see here, so a cylinder is a solid of revolution type, wherein it has got two bases, and again in this particular case these two bases, they are circular bases, and these two circular bases are bounded by a curved surface. That's the reason we consider them as a solids of revolution. Accordingly, we can also have what is known as a cone. So in the case of cone, if you want to generate a cone, we need to use a right angle triangle plane figure. Then if I rotate the right angle with the right angle as my reference, and if we rotate the other one, we are going to get what is known as a cone. Okay. Now as you can see, a cone has got one circular base, then it is having one apex. Obviously in this particular case, here also have a curved surface, here also curved surface. Now since they are having curved surface, if I consider any line on the circumference, we consider those lines as generators. Now as you can see, in the case of cylinders, generators are all parallel to the axis, whereas in the case of a cone, generators are all inclined to the axis. So now since they are inclined to the axis, we consider these generators as slant generators. Finally, we have a sphere. So what is a sphere? A sphere can be generated from a semicircle. Let us say if I rotate the semicircle with that diameter as my fixed reference line, if I rotate by one rotation, I am going to get a sphere. So as you can see, in the case of the sphere, the center of the diameter itself is the center of the sphere. Okay, so this is about the introduction of different types of solids what we have. Apart from this, we have two more terms which we are going to use, what is known as the frustum of a solid. So what is a frustum then? So I can say a frustum of a solid we can get either in the case of a pyramid or in the case of a cone. So let us say we consider a horizontal suction plane. So if I am considering a horizontal suction plane cutting the top portion. So if I just remove the top portion, then the remaining portion can be considered as a frustum pyramid. Similarly, in this case I am going to get a frustum of a cone. But remember, I cannot get a frustum in the case of a prism, because even if you consider a horizontal suction plane here, what will happen here? Only thing is the height of the prism will decrease. So shape will remain same. That's the reason we can say we are going to get only a frustum of a pyramid or frustum of a cone. Apart from that, finally, we can also have what is known as a truncated solid. So what is a truncated solid? A truncated solid is a solid which is cut by any suction which is not horizontal. So if it is cut by a suction plane which is inclined to the base, then the resulting solid can be considered as a truncated solid. So obviously a truncated solid I can get in any one. That is, either I can say truncated pyramid, I can say a truncated cylinder, or truncated pyramid, or a truncated cone. Finally, we have what is known as oblique solids. So what is an oblique solid now? Because I told you that generally we consider only right and regular solids. If I say oblique solid, means the axis is inclined, because all the cases what I have just now dealt, wherein all the way the axis is perpendicular to the base. In the case of oblique solids, axis will be inclined to the base. Now I am just going to demonstrate the different solids what we have in our department. Okay, so let us consider this now. So what is this? So I think all of you can just make out this. So this is nothing but a prism. Why this is a prism? Because it has got two bases. That is, it has got a top base, it has got a bottom base. And these two bases are bounded by parallelograms, or I can say faces. They are all lateral faces, I can say. So I can just consider this to be a prism because it has got two bases. Now I need to say which type of prism is this. That can be judged by seeing the shape of the base. So if you just see the shape of the base here. So as you can see here, the shape of the base is a pentagon. Since the shape of the base is pentagon, we consider this particular prism as a pentagonal prism. So this pentagonal prism means it has got 5 sides. Okay, then they are all bounded by these faces. Now for this particular prism, I can identify different edges. So generally we consider edges as either base edges or longer edges. So what is the base edge? That is, the edges which are going to get at the base can be considered as base edges. Now as you can see in this particular case, since it is a pentagonal prism having two bases, we can say that we are going to get 10 base edges. That is 5 on the top base edges, bottom we have another 5 base edges. Now we are also having these edges, and these edges they are all perpendicular to the base now. So we consider them as longer edges. And remember always these longer edges are parallel to the axis. So you can say this is the axis now. So since your longer edges parallel, they are considered simply as straight edges, but straight edge is not a better word. So generally we say a longer edges. Now I can say this particular prism has got, since it is a pentagonal prism, it has got 10 base edges. Then how many longer edges? It has got 5 longer edges. Let us say we have a prism of this. So what type of prism is this? I think you can just identify this now. So what is the shape of this? The shape is a rectangle. Now since it is a rectangle shape, since it has got two bases, we consider this particular prism as a rectangular prism. And again this rectangular prism, since it has got 4 sides, then we consider this particular, we have 8 base edges and 4 longer edges. Okay, now we can see this also. So what is this? As you can see, the shape is a square one, and it has got 2 squares or 2 bases, so it is a prism. So prism is having square as the base, can be considered as a square prism. Okay, and as usual, since it is a square prism, it has got 4 base edges at the top, 4 base edges at the bottom. So total it has got 8 base edges, then it has got 4 longer edges. Then it has got how many faces? 1, 2, 3, 4. Now since it is a rectangle, all the faces are not same. Only the base edge which is smaller having base edge. Anyway, I think it is a square prism. It is not a rectangular prism. So for a square prism, all the faces are having rectangles. Yeah. Now we can just see this. So what is this particular solid? You can identify this to be a pyramid. So why it is a pyramid? Because it has got only one base, and we have this isosceles triangular faces. They are all going to converge at a point, and that particular convergent point can be considered as an apex. So I can say this is a pyramid. And what type of pyramid is this? That can be decided by seeing the base. So what is the base here? It is an equilateral triangle. So I can say this is an equilateral triangular, or simply say a triangular pyramid. Okay. Then as you can see, this particular triangular pyramid has how many base edges? Because since it has got only one base, and since it is a triangular pyramid, it should have only 3 bases. So I can say this is having 3 base edges. Then these are all, because they are all triangular faces, they are all joined by one another now. So we consider them as the intersection lines to be edges. So what type of edges? Because I told you that in the case of prisms, we are having a longer edge. Why it is a longer edges? Because longer edges in the sense, as you can see here, in this particular case, all these edges are perpendicular to the base. Okay, but if I just see this particular pyramid, all these edges, they are all inclined. Now since they are inclined, we consider them as slant edges. Okay, so we need to distinguish. Now since it is a triangular pyramid, I can say it has got 3 base edges and it has got 3 slant edges. Of course, we have this axis also perpendicular to the base, which starts from the apex, and we consider this pyramid correctly as right and regular pyramid. Why it is right pyramid? Because the axis is perpendicular to the base. Why it is regular? Because all the sides are having same dimensions. Then I am going to show this one. So as you can see, so can identify. So what is this? So as you can see, it has got 2 circular bases bounded by a curved surface. Since it is having 2 circular bases having a curved face, we consider this particular solid as a cylinder. So I can say a cylinder has got 2 circular bases. I can say top base and bottom base, and they are bounded by this curved surface. Again, the axis here is perpendicular. Okay, now let us say if I have a cone, what do you expect? That a cone will have only one base, then you have again a curved surface. But here you can observe, I can just draw a line from top base one point to the same point or a similar point at the bottom. So if I just draw an imaginary line here, that particular line can be considered as a generator. Remember, there I said we have edges. Now here no question of edges in the case of cylinders and cones. So we have only generators. Now since these generators are parallel to the axis, we simply consider them as generators. But whereas if I consider the cones, in the case of cones, the generators will be inclined to the base now. So we consider for cones the generators to be slant generators. So I think I have just covered now the introduction part of solids.